So this lesson is on linear inequalities. This is just another skill for this first unit, which is just covering a bunch of different skills that will help you throughout the course. This is another one. It's probably new to you. Basically, we know what an equation is. An equation like 2 times 5 plus 3 equals 13. Well, 2 times 5 is 10 plus 3. This is true, right? Our left side equals our right side. We have an equal sign in the middle. This is an equation because we have terms on the left of the equal sign and terms on the right. So it's not an expression, it's an equation. It's a true equation because the left side equals the right side. But what is an inequality? So I understand that this might be something new, but you have seen greater than or less than signs before. A greater than symbol is always having the greater side, the width here, on the left. So I always imagine I'm reading these symbols like a book from left to right. So if I hit the larger side first, this is greater than. And if I'm going from left to right and I hit the point first, the smaller end, that is always the less than symbol. So we'll try and keep those two straight and always remember that. One thing that I'm going to suggest we do, we're going to have inequalities like the one you see down here. There's not an equal sign here between the left side and the right side. There's a greater than symbol. But what we have to do is we think back to even grade 9 math, where we solved equations and we isolate the x. We get the x by itself. We're going to do the exact same thing. There's just one important rule. If you end up multiplying or dividing both sides by a negative, we have to flip the sign. The sign has to switch direction. So the greater than sign becomes less than if we multiply or divide by a negative number. The greater than or equal to becomes less than or equal to. The less than becomes greater than, and the less than or equal to becomes greater than or equal to. So some questions might have a greater than symbol like this one. Other questions might have less than or equal to symbol. So you just basically follow along with what you're given. If it's a greater than or equal to or less than an equal or equal to, you continue on with that type of inequality. If it's just less than, you continue on with the same type of inequality. So let's look at example 1. We're going to solve this. Just imagine there's an equal sign here in the middle, and I want you to get the x by itself. It also says to graph the solution. For us, a graph is just going to mean like a picture of what we see. So what we're going to do, we're going to use a number line. We'll graph it in a second, but right for now, we're going to have our inequality. -5 is greater than x minus 2. If I want to isolate the x, I'm going to move the -2 to the left-hand side. And it might have been a while, but a -2 on the right, I would have to add 2 to both sides. So it would look like -5 plus 2 on the left. Now I'm not multiplying or dividing by a negative number. I'm just moving the -2 from the right side to the left side. And then -5 plus 2 is -3. And this is what we're left with. I don't know, -3 is greater than x. I kind of like the idea of having the x on the left-hand side. So I know the smaller point of the inequality sign is at the x. So if I said x is less than -3, I think that makes more sense to me. So when we look at our number line, we want to put enough numbers on so that we have maybe 0 in the middle and -1, 2, 3, 4, 5, maybe 1, 2, 3, 4, 5. I don't even think you need that many numbers. You can put a few on. I don't think I need it to go all the way up to 5. So think of this, x is less than -3. It's not equal to, it's not less than or equal to -3. It's just anything less than -3. So it does not include -3. So I'm going to put an open circle at -3. And it's anything less than that. So I'm just going to shade in the number line a little darker. And I'm showing an arrow that this number line, x is less than -3, would include anything less than negative 3, but not negative 3. So that's why I put an open circle around the negative 3, and then these numbers are all filled in. What that means is my number could be something like negative 100. It could be negative 4.5328. It's anything less than negative 3, including all decimals in between. So this means that the inequality will be true for every value of x less than negative 3. Example 2 on the next page. Again, I just want to isolate my variable, which is an m. So I'm going to move this negative 4 to the right-hand side. So it's going to become a positive 4. I would have to add 4 to both sides. So I know negative 3m is less than 9. In order for me to isolate the m, I'm going to have to divide both sides by negative 3, just like you would if you were solving an equation. There is an important thing here right now, is that I have to divide by a negative number. So when I do that, when I multiply or divide by a negative number, the direction of my inequality has to change. So my final answer for this one is m is greater than negative 3. So maybe put a little star beside that. I divided by a negative. So if I was going to draw a number line, maybe since it's anything greater than negative 3, let's say I just had negative 4, negative 3, negative 2, negative 1, 0, 1, 2. That would be enough. So if m is anything greater than negative 3, it doesn't include negative 3, but it would be anything greater than that. This is also, I should have said that on the first page, this is a set of real numbers. So we're not looking at, if we were just looking at integers, we would only have values of negative 3, negative 2, negative 1. But since we're talking about all of the values in between, all of the decimals, all of the rational and irrational numbers in between, our number line, if we had to sort of have an axis title for it, let's call it, we would say it was a set of real numbers. And then part B, they can get a little bit more difficult, just like they did when you were solving equations when you first learned. So maybe there's a little bit of distributive property right now, where I want to multiply by 4. And then maybe I would try and collect all of my t's together on the left. So I'm going to have to subtract 8t, move the 8t to the left side. And then I had 20, and I would add the 4. Add 4 to both sides. Negative 4 on the left becomes positive 4 on the right. So negative 4t is less than or equal to 24. Again, though, I'm dealing with a less than or equal to sign now, so I'm going to keep that same type of inequality, but I do have to divide both sides by negative 4 in order to isolate the t. And when I do that, I have to switch the direction of my inequality, and t is greater than or equal to negative 6. So what does that mean? This time it's greater than or equal to. So when I draw my number line, greater than negative 6. So let's put negative 7, negative 6, negative 5, negative 4, negative 3, negative 2. Anyway, it's anything greater than or equal to negative 6. So imagine this time the negative 6 is colored in. So because we know that it includes negative 6, it's not an open circle, we're going to color it in, and it's anything greater than that. So I might make this just a little bit thicker here and show my arrow that this number line, our values for our inequality are anything greater than or equal to negative 6. And then the last page, there's a little bit more to this, but not much. It's really not too bad. If you had a question that looked like this, negative 3 is less than 2x minus 1, and that is less than 5. That seems like sort of a confusing type of way to write it. You'll often see that written as negative 3 is less than 2x minus 1, so we know that part, and 2x minus 1 is less than 5. So they're often split up into two different inequalities. But you might see it written this way, and that's okay too. You just kind of split them up yourself. And I think it makes more sense to do that. So what if I have two different inequalities? We want to solve for x. X has to satisfy two conditions. So whatever we find here and whatever we find here. So let's just solve each one on its own. -3, I'd probably add the 1 to that side. So -2 is less than 2x. I'd have to divide both sides by 2, but not a -2. So I could leave my inequality. -1, I kind of like it written with the x on the left. X is greater than -1. And 2x minus 1, so let's say we move the -1 to the right. So that'd be 5 plus 1. 2x is less than 6. I can divide both sides by 2. So x is less than 3. So what we found out here is that x is greater than -1, and at the same time, it has to also be that x is less than 3. So how would that look on a number line? Let's say this is 0, 1, 2, 3, 4, -1, 2, 3, 4. I try and space them out so it looks like they're even. If x is greater than but not equal to -1, it would be starting at -1 but not including -1, and it would be greater than, so kind of going up in this direction. But at the same time, and x has to be less than 3. It doesn't include 3, but it's all the values in between. So we're going in between -1 and 3. Another way you can write that is -1 is less than x is less than 3, meaning x is in between -1 and 3. And then the last one is a question involving the word or. So this time it doesn't have to sort of satisfy two conditions at the same time. It can be one or the other. So let's just try and isolate our x. So I'm going to move the 2 over. That 2 to the right becomes a -2. 5 minus 2 is 3, but I would have to divide both sides by -1. So I divided by a negative, my direction of my inequality has to change. Or, so I have or, what do I have? I have -x, I'll leave that on the left. I'll move the 2 to the right. It's -1, whoops, -x is less than or equal to -1. I have to divide both sides by -1 again. So x is greater than or equal to 1. Or, so we have one condition or the other. All of the values that are less than or equal to -3, or x would satisfy all the values that are greater than or equal to 1. So how would that look on a number line? So x is less than or equal to -3 or equal to -3. So I'm going to color it in. Less than or equal to -3. Or x is greater than or equal to 1. Or equal to 1. Greater than or equal to 1. And in this case, because of the word or, we could have values that are less than or equal to -3, or all values that are greater than or equal to 1.